So in this question, this is going to be another one where we're working in units. So of this, we're going to be searching for or solving for units for our bolus, our milliliters for our bolus, and our milliliters per hour. So the same rule applies with this information. We want to write down all of our information from our question. So first off, I'm going to read the order. Begin a heparin drip per the facilities protocol. And here is going to be our facilities protocol for this particular dose of heparin. And our patient's weight is 84 kilograms. So that's going to be very important because obviously this dose is ordered per kilogram, as well as our infusion is ordered per kilogram. So what I want to do first is write down our order for our bolus, which would be, I'm going to put B for bolus, would be 70 units per kilogram. Then I'm going to go down here for our infusion. So I'm going to put infusion. So we want 17 units per kilogram per hour. And then let's go ahead and do our have quantity being 25,000 units and 250 milliliters of normal saline, or 100 units per milliliter. Always try to work in the smaller units, so I'm going to work with 100 units per milliliter. So let's go back up here, and we want to solve for units for our bolus. Then we want to solve for milliliters for our bolus. And then we want to solve for milliliters per hour for our infusion. So let's start off by doing our first problem, which is to find our units for our bolus. So we're going to put units here, and when we're doing this, all we have to use is our weight and then our order for our bolus. So with dimensional analysis, you always start with your what you're solving for at the top in your numerator. So we're going to put 70 units per kilogram, because that's a sentence. And since this is kilograms, we have to have kilograms here. And our patient weight is 84 kilograms. And our kilograms will cancel out, leaving us with 70 times 84, giving us 5,880 units for our bolus. All right, then we're going to go ahead and solve for our milliliters. So if solving for milliliters, I'm going to put milliliters on top. This is where we have to use our have quantity. And so in that case, we're going to put 1 milliliter over 100 units. And this is what we're going to plug in, because this is how many units for our bolus that we want. And in this case, we want how many milliliters to give in our bolus. So if this is units, we have to have units here. So that is going to be 5,880 units per dose for our bolus. Our units will cancel out. So then we have 5880 divided by 100, which gives us 58.8 milliliters for our bolus in milliliters. Now let's solve for our infusion. Again, since we have kilograms here, we need to figure out how many units per hour we give for a patient weighing 84 kilograms. So I'm actually just going to times and fill in actually and do 17 times 84, which would give us 1428 units per hour. Now we need to solve for milliliters per hour. With dimensional analysis, we always start out with our numerator here, and we'll end up with hours on the bottom. So we have our milliliters here. So let's put 1 milliliter over 100 units. And then we're going to plug in this here, and it's going to be 1428 units per hour. The units will cancel out, and that leaves us 1428 divided by 100, and that will give us 14.28 or 14 milliliters per hour. So here's your answer for our units for our bolus. Here is your answer for milliliters for our bolus, and here is our answer for our milliliters per hour.